that valve is currently controlled by this setup, which is less than ideal, especially when you have a passenger here. To open it, we go like this, and then it's open, and close it. Switch in the opposite direction, polarity is reversed, motor's happy. So I've had that set up for a number of years now, and it's pretty annoying, so I'd like to switch it to a wireless controller, and currently the prices for the OTP controller are over $90, which brings us to the point of the video today. Today I'm going to show you how to make your electric exhaust cutout controlled wirelessly for only about $20 worth of parts, or maybe even a little less. We've got this switch here with a fuse and this connector, so basically all we need from this setup is everything, but we want to put this somewhere a little more stealth. And let's get down over to the battery, and this comes out of the control valve, which we will eventually shorten, and then we're going to take the positive and negative going to that switch, which goes all the way up there, and we're going to make that a lot shorter and mount our new relay somewhere maybe up in here or wherever we can find space. Oh, and hey, what's that? Is that an active EKP cooling module from Terminator.com? Sure is. Link in the description below. This is going to be the device that will replace this switch. What this is a wireless relay that operates on 433 megahertz, and it's rated for up to 30 amps, and I think about 350 watts, but we're not going to be putting anywhere near that much through it. So what this will do is open and close and also reverse polarity, which we're going to need in order to make the flap go from closed to open and then back to closed again. So I'm going to show you how to program this with a different remote, because the one it came with is big and I wouldn't have a place to put it on my already way down keyring. But before we do that, let's go ahead and send this back through the car and into the trunk. And it's been a couple years since I did this, so kind of have to remember where it goes. And it looks like the wires come out through down here, which was only ever supposed to be a temporary thing, but it's turned out to not be. And we're going to pop off this panel and the back panel here, which will give us access to put those wires back through the trunk. And in order to do that, we're going to just pick up the seat back here and over there, and then throw this whole thing out. And then to get the seat backs down, what we're going to need to do is come back into the trunk, get a screwdriver up in here, and then just turn this or push it as much as you can. Each car in E60 is different, but this is just more of an overview on how to save money from instead of buying that expensive OTP part. But yep, that's how you get the seat backs down. All right, so now I've got the wires from up there and the switch, and we don't need to take the seat back all the way off. We're just going to try to shove these on through, and they come out somewhere about where you can't see them, and they just kind of sneak through there, so we'll pull them up and through. So now that the wire's all pulled through, we're going to look for a place to mount this, and since this area is kind of full and that area is kind of full as well, I think for now I'm just going to put it up here somewhere and maybe zip tie it to this wire loom as a temporary solution. But eventually I want to make something 3D printed where I can bolt and unbolt this too. Since I kind of have a good idea of where it's going to go, let's just figure out how much wire we need. And we probably only need about this much, whatever that translates to in millimeters. You can do the conversion at home. And we're going to cut the power and the negative. And I would recommend, if you have yours connected to the battery, to unplug it now. If you have a QTP cutout, chances are that you'll also have a connector that's similar to this, or kind of looks like this. Here's the female end of it. And if you want to retain your plug and play ability, you should get one of these connectors, and there will be a link in the description below to where I got mine. So once I measured out everything I needed, I decided to ditch the old wires and then put some new ones on with some fresh connectors, properly crimped and heat shrunk. And I also added a fuse into the circuit and heat shrink butt splice this. And if you're wondering why I didn't solder that, because I don't have a soldering iron. So yeah, that's the reason. It's just because in a low amperage, low voltage thing like 12 volts with barely any amps coming through here, a heat shrink butt connector will be just fine for the job. So now we're going to sleeve this up with some sleeve, make it look nice, add some ferrules, and then get it in here. So I'm just about to finish up the hot side of things, and I realized, well, if I cover this with the sleeving, it's going to be very hard to get at the fuse. And I haven't blown this fuse ever, so I'm hoping that I can just cover it up and get away with it. But I found out that there is this fuse in there, which is a 2 amp fuse, and fortunately I have a few of those around. So now I got the fuse in there, and we can continue the sleeving. So these are how they came out. This got the ferrules on here, which probably won't focus, but that's alright. And a nice heat shrunk crimped end, same here for the hot side. So now we're going to pop them into this relay and then wire this guy in as well. And since this comes with a remote that's kind of large and doesn't have anywhere I could put a keychain on it, I want to use this remote, which is another 433 megahertz remote that I got off of Amazon, and I will have a link in the description below for this as well. So we'll be going from this detonator looking thing to something that's more of an appropriate key fob that'll just fit nicely on my key ring. So as you can see in here, there's two relays. One is going to be for normal polarity, the other one's going to be for reverse polarity. I don't know which one is which, but they're both there for a reason. So in order to program this remote to this, what we're going to do is we're going to first loosen up these screws here and get some power going to it. Turn on our power supply, and it should be at around 12.3 volts, which is, you know, it's kind of normal car voltage. And we're going to check out to make sure this works. All right, so that means these relays are working, and the stop button, I don't anticipate it doing anything anyway, because we have this currently set in momentary mode. Now there's also latched mode, and I forget what other mode's in here, but we're only worried about momentary, which means this position should be, or this jumper should be on the JP2 position. In order to program this, we're going to take the jumper and we're going to put it to JP1. And just to test that it's on latched, we're just going to hit the down button real quick. And you can hear that the relay has stayed open, or closed rather, so now the stop button, now the relay's closed, or open. So now that it's in that mode, what we can do is we can hold down each one of these buttons, and we'll start off with the up, which we're going to have programmed to this up button, and hold it down until we see the LED turn on. Then once it's on, hold it up, it's flashed, meaning it's good to go. Okay, and then we're going to do the same for each one. Just so the middle one now, LED's on, middle button, got it, good to go. And now we're going to do the bottom one. So the bottom one's going to be this one. I think LED's on. 2 clicks, we're good, or 2 flashes, we're good, so let's see. Nice. Awesome. So why don't we go ahead and switch this back to normal position. All right, so we've just jumped back to momentary, and let's give this a go. And the stop button should do nothing as expected. For this next part, we're going to leave this open because we're going to have to figure out how our wires go, and we need access to these. Before we move over to the car side of things, let's test this with the multimeter first. So right now the power supply is set to 12.3 volts, and we should be able to see that on the meter. And yep, there we go, about 12.39. And now let's check on the output side of things. The orientation doesn't matter too much, just for testing, because we're going to see what we should see, rather, is 12.3 on the up and then negative 12.3 on the down. So let's try that now. So here we go on the up, and 12.38. And then on the down, negative 12.38. So this is working as expected. I've come to a bit of a realization that these holes are too small, so it's time to make a bigger hole here. Well, I only managed to make that look pretty ugly, and I kind of jacked up the port there a little bit, but it should be fine. Well, due to the last fiasco with the fitment, I decided to forgo the ferrules for this connector, and just kind of put them in there like that, which that should be just fine. So these are in there pretty solidly. And we're going to go back over to the car. Well, first we're going to close this up. Then we're going to go back over to the car with some zip ties and get this all installed. So I have the wires kind of run how I want to have them run when I put this unit all the way up here somewhere. But we can see that the negative goes to the negative, positive goes to the positive, and I'll put these out of the way with a zip tie. Before I connect the valve to the relay box, let's just make sure that it clicks on and off. I don't know if you'll be able to hear that. All right, it is clicking. Let's connect the valve and see if it opens and closes. Oh, look at that. That is awesome. All for under 20 bucks too. And there we have it. It's tucked up away there and zip tied to that harness. It's not causing a whole lot of pressure on the harness because the box is nice and light and the zip ties aren't cranked down all the way. The wires are pretty much out of the way and ran is about as clean as I could do them here. So let's see what it sounds like inside. So if you guys want to see an updated exhaust video now that I've got this on this, and I did do a couple different things with my exhaust since the last video. So if you want to see that, leave a comment below and I'll gladly get to it. But that's going to be it for this video. I hope you guys learned something. So if you did, make sure you hit the like button, subscribe if you want to see some more cool DIYs coming up. I have a whole lot planned. And share it with a friend if it might be helpful for them. And remember, as always, keep it foul.